Welcome to Sravz Technical Series. In today's session, we'll discuss the Boost REST API models. In the previous session, in the fundamentals controller, we discussed the pre-signed URLs generation, and then we send the response back to the UI. But that response was in a string format, not a JSON format, and our UI looks for output in a JSON format. For example, this is the format it expects, and we were sending the output in JSON format. So today we'll upgrade the Boost REST API server to serve models, and using the models we'll convert the model to a JSON format so it can be sent as a JSON output. So at a high level we'll discuss these sessions, these topic. We'll first do a quick demo of the production setup. It is already deployed to production. I'll show those, and then I'll discuss the fundamentals controller and pre-signed model integration and the updates to the router so that the model is used by the controller to serve JSON output. And in this process, we'll discuss these C++ concepts, multiple inheritance, etc., templated functions. Switch back to the UI. The UI is now integrated with the Boost REST API server. If I go to the headers and the response headers, it shows Boost 351, version 351, and it is serving application.json format. And the payload is in this format, so it is sending us a JSON file. I'll click another fundamental mutual fund, so AADSX, and then we're getting the AAGX. This is the previous request, AADSX. So we are getting the response from the Boost REST API server, which is at version 350. The production works. Now I'll go through the code base. We have used Interitance this time to create the models. I have the base model.http, which is the base model, and our goal is to create all other models based off the base model. The base model is an abstract class because it has a pure virtual function equal to 0, and then the base class will also take params, key value parameters, and it will save them in a map like this. So the base class will be common across all the future models, and the base class will contain the params map, which is the parameters we send from the UI, the Angular UI. In the pre-signed URL model, which is inherited publicly from the base model, we'll set all the attributes that are required for the pre-signed URL model, and then we'll override to JSON, which is implemented in the base, which is declared in the base model. Since it's a pure virtual function, we have to override it. So we use the keyword override. And since there's no compilation error, that means the compiler has ensured that we have overridden it, because our return type matches what is expected here. The return type is std string, and there's no parameter. Similarly, there's no parameter here. So override works here. So that's the purpose of the override key. When we mention override, the compiler will check that we have overridden the base class pure virtual functions. Now we'll switch back to the fundamentals controller. The fundamental controller in the same way will inherit from the base controller. The base controller has the constructor protected so that we don't create an instance of the base controller. Only the derived classes can create an instance of it. So that way only the derived classes can be created. We don't create the base controller directly. And I said these two functions not pure virtual functions because these virtual functions take the parameter of base model, and then the derived class, when it overrides them, I'll go to the CPP file, fundamentals controller.cpp. When it overrides the functions, it takes the derived class as a parameter. It's okay to return a derived class as the value from the function, but the parameter has to be the same parameter as in the base class. Here, since we are using a derived class, it is a contra variant, and C++ doesn't support contra variants. It has to be of the same type. So we have to use the parameter as the base model here if the override has to work. Since I'm using a derived class as the parameter, I cannot use the override keyword, so that's why I commented that out. The other option I could do is use the parameter as the base class, and then in the function, before doing any processing, cast it, the base class, to either statically cast or dynamically cast to the derived class. So we downcast it using dynamic casting. But the issue with static cast is it will check during the compilation, it will check, but it can throw a runtime error if somebody calls the function with a derived class pointer or a reference. The static cast is only checked at the compile time. If we use the dynamic cast, it is checked at the runtime But the issue with the dynamic cast is it will involve performance penalty, and it's a big performance penalty because this function will be called for each request from the user. So we cannot keep dynamic casting the code base for every request we get from the user. If the request at a high frequency to this controller, dynamic cast will slow down the controller. So that's why I didn't use the dynamic cast, and I didn't use the override keyword. I let this function be freestanding. It's not an override of the base class. And since we made the base class constructor protected, it's no one will create an instance of the base class. So that way it's a trade-off. So if you cannot override the base class functions, then just make the base class constructor protected. Now I'll go to the router. In the router we discussed in the previous sessions, for each route, for example, the UI will have fundamentals in it. The URL will have fundamentals in it. Based on the URL which has fundamentals, we call this section of the code. The router will take this section. And in the previous code base, we're doing a lot of processing of the params, and then we call the controller like this. Instead of doing that, I wanted to make it generic by using templates. So I created this function route to controller. The route to controller is a templated function which will take two template parameter types, the model and the controller. And then it will take the params map and the forms controller pointer, shade pointer. So route to controller will go here. Route to controller will take T1, T2 as the parameter types I showed. So we create a model by passing params map, and this one will be saved in the base model params map. And then on the controller, we call validate request function and pass the model. The validate request on the controller will check if the model is valid, if it has all the required parameters to process the request. If not, it will send the HTTP, it will not set the status to OK, so we'll send a bad request. If validate request gives the correct model, validate request will update the model. Since it's passed by reference here, validate request takes a reference. Validate request takes a reference of the model, so the model will be updated. It's not copied, but it will update this model. So we'll use the same model, we'll pass it to get, and then the get will again passes the model with the updates. The get will call the S3, creates the presigned URL, updates the model, and then we take the model and then we return the status. The controller will set the status as success and HTTP OK, and then the model is now complete. It has all the information we need. So the route to controller will call toJSON function, which is implemented in the base model, which is overridden by the presigned URL model, and then the toJSON will return the JSON out. So if I go to the controller, to the base model, fundamentals controller presigned URL.http model, that model to JSON is an override, and it returns us using Boost JSON library. It will give us the output. So right now we have hard-coded these key value pairs, but at a later point we can see if we can do it through some text generation or some automated tool. So that's how the router will send the response back to the client. And the rest of the code base is the same. Everything is same. Eventually we'll remove all this boilerplate code and we'll call route to controller like this dynamically. So this way we can clean up the router. And also at some point we'll update the router to use dependency injection. Right now we are creating a bunch of these shade pointers, but at a later session we'll use Boost dependency injection and create all the dependencies that are required by the router. And that way the router code will be much simplified and the test cases can be run. So I've created the test cases for this, and the test cases load and they all run successfully. So created a test case for the models and it was running. Now I won't run the test case, it will take a while since I demoed that in the UI in the web browser. That shows that the code base works. So with that, I'll close today's session. If you have any questions or comments, please reach me out in the YouTube channel or in the discussion tab here. Thank you for watching.